So I'm Wes Hardaker. This is actually the work of sort of 4 people that I'll cover more at the end. And my point today is that you can stop sending stuff to the root server system. You don't need it anymore. So I don't even want to explain this slide because you're all engineers. You know how the DNS works, right? But essentially all resolutions have to go to the root at some point, or do they? So way back in the day, the DNS root system looked like this. It was a machine under a desk. I know because I inherited one before I took over a root server. The good news is this is the only AI-driven drawing in my deck. The bad news is you'll see it twice more. This is Jeff Houston's diagram of the growth of the root server system traffic in the last number of years. Note that since 2023, we have increased the growth of the traffic to the root servers by 40%. The sad thing is that most of this isn't even for real answers. 2/3 of the stuff that the root gets is just junk. It's just random stuff. A lot of times I go look at our traffic patterns and it's like some guy that's decided to query for like every IP address on the planet. And obviously IP addresses don't work in the root because there is no .1 and .2 and .3 in the root. So this is what the DNS root looks like today. It's no longer just this machine under a desk. It is 2,000 nearly instances all over the planet. And that's not paid for by anybody. That's the downside. So we're all doing it sort of, for free. So I'm going to declare that this is not actually progress. This is actually bad. We don't want 2,000 instances all over the planet. We've had to do this to deal with scale. We've had to do this to deal with the growth of the root. But this is not actually good engineering, right? It's expensive. Why would we do this? So we're headed in the wrong direction. And it's the wrong direction because the root has become such critical infrastructure that it can't go down, right? It is the bootstrap for like everything on the planet. It's a target of DDoS attacks as well as a bunch of other stuff of yours. And it's constantly increasing traffic loads as the graph a minute ago. Thus, it can no longer sit underneath a desk. But what if it could? What if we could make the root server system actually go back to being underneath the desk? What if you already had all the answers? Would you need to send me traffic? No. Right? What if then the root server system was just an emergency backup? Only when you absolutely needed it as opposed to needing it every day all the time. So I'm a root server operator. I mentioned that before. I work for Google now. Previously, I worked for USCISI, and I was the principal operator of broot. I'm still heavily involved with broot and still participating in it. So, you can trust me when I'm asking you to please stop sending me traffic. Right? I don't want it anymore. So now I'm going to explain how. Right? And the how is you have resolvers out on your network. Have them cache the root. It's readily available. It's actually old technology. Starting in 2015, RFC 707006 was published saying, hey, resolvers can actually just use this local data. You don't actually have to send it to the root anymore. There's been a lot of other stuff that's happened since then. The LocalRoot.isi project is mine. It actually spits out bind and unbound and not configuration for you so that you can just pull it. I wrote a paper on analyzing and mitigating the privacy with the DNS root. All those weird queries that get sent to us, they're all possibly privacy leaking. Jeff Houston talked about it earlier, right? A lot of stuff has been done since then. So it is now time in 2026 to standardize it. Sort of before it was something you could do. It's actually now something we're trying to push as a recommendation. I have peers that are headed to Indonesia next week that are going to talk about the same thing. They're recommending it to everybody. It's time to make it the default. So it's time for you to deploy this. Anybody have resolvers out there that you're in control of? I would hope so. In Nanog, yes, a few, right? Anybody using local root type stuff yet? 1, 2, 3. Excellent. You guys can go home. It turns out that a lot of people are starting to do it, right? So this is a graph of unique sources headed to broot since 2017. Queried once, queried daily. They're querying daily. The data points are once every 3 months just as a sample. And since you guys are Nanog, you actually don't care about unique sources because they can wander. This is unique ASNs. Still quite a few, right? Sending us traffic. AXFRs are the DNS protocol option to pull the root server data in its entirety to you. Okay, so how do you go about doing this if you want to do this? It's actually really quite simple. The data is readily available. You can get it from your local config. You can pull it with wget out of, out of cron. A lot of resolver implementations can already do this. It's available from IANA. You can get it by carrier pigeon. I actually don't care because it's signed. Literally, if it was spray painted on the back wall, okay, you'd have to update spray paint frequently, but you can get it anywhere. So this is an example of the config. It's actually quite simple. This is for not resolver. There's a prefill module, and so that's one of the things that the newer stuff does is it prefills the cache with the root zone. Bind is even shorter. You can't get shorter than that. Unbound is quite short. It says go get it from IANA. Thanks, done. So why do this? What's the benefit, right? Obvious than all the stuff that I said of like why would you release privacy? I've talked about that. It's secure, right? DNSSEC and ZoneMD, which is a record in there, jointly together say you have the correct root zone. You have the IANA root zone. You need to look no further. Even if you're not distributing DNSSEC related signed data yourself, you can still verify that you're not getting a modified copy of the IANA root zone. It's more robust. We're going to actually look at having multiple providers, CDNs and other stuff, actually offer it besides just IANA and besides just the root server operators. And you only need to fetch it 2 or 3 times a day. So it only has to be up occasionally, and it can survive a DDoS attack of your network for 24 hours, unlike the root server system where you're actually probably querying it much more frequently. The one thing I wrote into my paper about analyzing privacy is the only way to really, really, really be private is to know all the answers ahead of time. If you never have to send a question out, then it's not releasing anything, right? The root makes it really easy to do that. It's more performant. You can't get faster than an RTT of 0 milliseconds, right? If you have a copy of the root, right there. Now, actually, the latency to the root doesn't matter, but we keep failing to convince people of that. And you would think it's a really big file. No, it's really, really small. The maximum worst case transfer episode we've seen is 2.4 megabytes. If you can't handle that 2-3 times a day, then you're in the wrong room. So this is the resources. A couple of things. This has been around a long time. Almost all the resolver implementations actually allow you to use it already. We are advancing 4 drafts in the IETF that are sort of updating it and making the drafts actually match the current implementations, and talking about having IANA actually create a list of publication points beyond just the root servers. The LocalRoot.isi is actually my pet project that allows you to sign up and you get some other features. You get actually a notification when the root server changes its data and things like that. Not really necessary, but it does make it easy if you want to sign up and get config from it. The really cool thing, out of all the people for the years that I've been running that service, the number of errors that I've gotten from people, the number of times people have said, hey, it's broken, 0. It just works. So from 2015, I've had 0 people say it failed on me. Feel free to write me with questions. Feel free to join the discussion on DNS op at the IETF. And if you just search for LocalRoot DNS, you'll get to all of the wealth of information. So if you just remember that, you're good to go. That's it.
Hi, Brian Fields, Tampa IXTBAX. I had a question about the LocalRoot thing. I actually just signed up for an account. That's kind of cool. And I did step out of the room for like 1 minute during that. Does that support the Power DNS recursor?
I need to go back and look. There's a number of things that I want to go put into because the config that I put on the screen is actually the simplest. When I created the LocalRoot project, it was when that easy config didn't exist. My LocalRoot project at ISI also allows you to get other data. So we give out ARPA and rootservers.net, which is also helpful. You can actually get those from the root servers today as well as because I can do anything. I actually added dnssectools.org because that's mine. I actually looked at adding some ccTLDs. One was small enough. The large ones don't really work. You never want to cache COM, right? It's too big. So there's some other benefits of using that website, but if you go steal the slides from this presentation later, you can copy and paste that config and just insert it.
Okay.
The LocalRoot site was tried to make it as easy as possible for everybody to use.
I was screwing around with it, so thanks.
Yeah, thanks.
Michael Sinatra, ESNet. I think the first time that the RFC that was written for doing for caching the local root, the question for Wes, by the way, was it said to run a separate server, separate instance on your loopback, and then have your recursive server query the loopback. And I think the reason for that was to validate the results coming from that fake root instance that you had just put on your loopback.
There are a number of reasons in the last 3 months when I've rewritten from scratch that RFC that we hope to publish again. It gets rid of all of those restrictions. It instead talks about what the expectations are of the service. You must check the data that it's authentic, right? That's critical. We don't really care if you run it in a parallel service, if you pre-fill your cache, however you do it, it really doesn't matter. So there's a significant change from 7706 and 8806. This did exactly what you said, that you have to run a parallel copy. Turns out, none of the implementations did that, right? So all of the implementations that I showed config for, they're actually not conformant to the RFC because that wasn't the best way to do it. So the new documents will actually match what the real world is already doing.
Okay, so there is still an advantage to doing it that way because you're validating the data, or is that advantage negligible? Or
you can validate.
That was really my question, by the way.
Yeah, no, fair enough. So when you get a copy of the root zone, if you look at the zone MD record, which is a checksum over the entire thing, you know that you have everything and that nothing's been modified. If you check the DNSSEC signature on the zone MD record, then you know that that record is good. Full stop.
Got it.
You actually don't have to check anything else in the file.
Okay, thank you.
Yep, thanks.